Hello everyone, welcome to my channel Code with GD. In this video, I will tell you about how large-scale distributed systems handle millions of tasks very smoothly. I will tell you about message queues, what is a message queue and what problems does message queue solve in your distributed system. I will also tell you what will happen if you don't use message queues in your system. So let's begin. By the way, this video is part of my message queue playlist. In the subsequent videos, I will talk about RabbitMQ and its components. I will also code for RabbitMQ, and after that I will move on to Kafka. So let's start this video. Make sure to subscribe to my channel to not miss any other videos on message queue. Assume that I have a video editing service. This service performs a lot of different tasks. One of them is a rotation service. Whenever a rotation task comes to this service, it redirects the request to the rotation service. This video editing service needs to directly communicate with the rotation service to handle the video rotation task. So this means the video editing service needs to know where to send the task. This means that my video editing service needs to know the interface of my rotation service, the receiving interface. Any change in the endpoint of this rotation service that receives the data will mean that the video editing service will also need to change the interface or the endpoint by which it sends the data over to the rotation service. This is an indication that both the services are tightly coupled, and this becomes a problem when you try to scale your application. This video editing service also communicates with several other services for video editing purpose. It can't keep track of what is changing or which interface is changing in which other service. This becomes a problem in the long run, so tight coupling is an issue in such cases. Now what happens if for some reason my rotation service is down? In that case, the request that my video editing service sends over to the rotation service, it will fail. Once the request fails, my video editing service needs to have a system of retries where it keeps retrying the same request until the rotation service is back up again, in which case the rotation service will take up the request and process it. If my video editing service does not have the system of retries, that request will simply fail. So there is a chance that the request may get lost. Also, what happens if my rotation service is doing some task and it gets an influx of requests from the video editing service? My server will get overwhelmed and eventually it may crash. So what happens with these requests? My rotation service already read those requests, but since it crashed, we lost the incoming request. So this is a problem when my main service directly wants to communicate with my rotation service. So there is no easy way to handle large influx of data, which leads to scalability issues. This is where message queues come in. One way to solve this problem is to have some kind of broker between my video editing service and my rotation service. This broker can receive the task inputs from my video editing service and it can send the messages to the rotation service. This can act like an intermediary layer between my video editing service and my rotation service. This is exactly what a message queue does. It acts as an intermediary between two different services who want to communicate. Introducing this message queue reduces the tight coupling that we had earlier between my video editing service and my rotation service. This video editing service pushes the data to my message queue, and this rotation service pulls data from the message queue whenever it is ready. Now, any change in the interface between these two don't affect the other services. So my message queue has removed this problem of tight coupling. This message queue is like any other queue. You can think of it as a first in first out system. Video editing service sends the message to the message queue. My message queue can store the messages in a queue format. The rotation service pulls data from my message queue. So first this will read the message 1. It will consume the message, and in the meantime my video editing service can put in more requests into the message queue. So it can put in message number 6 and then message number 7 Even if the rotation service is down, the video editing service can keep on adding messages to the message queue and the request won't get lost. So the problem of request may get lost is also resolved if we use a message queue. And now my rotation service has the liberty of just accepting one request at a time. So when my rotation service is free, it can pull another message from the message queue. It takes up the request number 2. It takes its own sweet time to process the request, and once it is done processing the request number 2, it can go to the next message, which is request number 3. It takes the request number 3 from the message queue and processes it. So there is no possibility of my helper service getting overwhelmed with a lot of requests. So this problem is also solved if we use a message queue. In the event a lot of requests comes in, the message queue can just keep on storing more requests, and the rotation service can take its own time to process those requests. If you want to increase the rate of processing, you can add one more service, and both of these services can simultaneously read from the same message queue to process the requests at a higher pace. So we can now scale our system in a more elegant way. My problem of scalability issues is also resolved with this. In simple words, the benefits of using a message queue involves we decoupled our system. The video editing service can now talk to many other services using this message broker, also known as message queue. So now I have a highly decoupled system. The sender and receiver don't need to know about each other to send messages, and it is fine if the receiver is down. The sender can still send messages and the receiver can read from the message queue whenever it is online. So this means my system is now resilient. Resilience because even if my system is down, the messages are stored safely. And since we are using message queue and different services can read from the message queue, I have created a scalable system. Also, introducing message queue increases the efficiency of my system. Efficiency how? Because we can divide the messages into different priorities. So for example, I can have a different queue and I can label it as this is a high priority queue. Now if a message comes from a client that has paid for a higher tier for his request to be processed at priority, the rotation service can first read from the priority queue. If the priority queue is empty, it can read from the normal queue. So these are some benefits that you can add along with the message queues. In short, a message queue helps you take control of your chaotic system. It increases resiliency and makes your system more scalable. It also reduces bottlenecks in your system. So this is about message queues and why you should use message queues and what happens if you don't use a message queue. In the next video, I will talk about RabbitMQ. I will talk about different components of RabbitMQ and then I will code for RabbitMQ. So stay tuned and subscribe to my channel Code with GD. Till then, happy coding. Bye bye.